Ben Harris, PE, is the Director of Engineering with Huckabee and Associates. Huckabee is a 190-person architecture and engineering firm with offices in Austin, Dallas, Fort Worth, Houston, San Antonio, and Waco. Huckabee was ranked #1 as the 2015 Best Structural Engineering Firm to work for in the nation by the Zweig Group. Ben has a bachelor's in civil engineering from the University of Texas at Austin and a master's in structures and applied mechanics from the University of Texas at Arlington. Ben has 18 years of experience as a structural engineer. He has designed many tornado shelters for schools using both ICC 500 standard, referenced by the 2015 IBC, as well as FEMA P361 guidelines. These shelters have consisted of various construction types, such as the cast-in-place concrete, insulating concrete formwork, precast concrete, and hot-rolled steel construction. He has worked closely with the architects at Huckabee to develop structural shelter solutions that fit the specific operational and aesthetic needs of schools. This collaboration has required an adaptation of ICC 500, which was not written with the intent to be a requirement for schools. And as he has worked with many of the members of the ICC 500 committee to develop this adaptation and assist with the development of the upcoming ICC 500 commentary. To share what he's learned in the process, Ben has given many presentations around the country to architects, structural engineers, contractors, and school administrators on the application of ICC 500 for schools. He has been actively involved in building code development through the Masonry Society for 12 years. He currently serves as the chair of the National TMS Disaster Investigation Program, and he works on numerous TMS committees, including TMS 402, ACI 530, AC 35, and TMS 403, which are both referenced by the IBC for Structural Masonry Design. He was the chair of the TMS 403 Design Practices Committee for 5 years. And now, Ben Harris.
And it's not wanting to. This will work.
All right, well, thank you, Alexis. Many of you may not know, but the 2015 IBC requires tornado shelters in all schools and all first response centers, like police stations, fire stations, 911 call centers, over about a quarter of the United States. And so today I'm going to talk about the tornado shelter requirements, and this is specific for schools. If you were to ask how necessary is this, you would, in a dialogue with the community, a local authority having jurisdiction may want to have a sense of how appropriate this is. FEMA is the one that sponsored these changes to the International Code Council for the IBC in the 2015 version. And in their justification, they referenced their history, and you can actually access it at this website for the last 50 years. It's very easy to use. You can just select in the country where you are, and you'll be able to see over the last 50 years how many tornadoes have occurred and what types they are. And the new requirement for schools is in its entirety on the screen in front of you. It's not very large. It says that Group E occupancies, which are educational occupancies, have to have a shelter for a 250-mile-an-hour wind speed per that ICC 500 standard that was referenced earlier, and that's for all of the occupants in that building. That's for anything with more than 50 people in the occupant load. And has to be, there are some exceptions where you have daycare facilities, places of religious worship, or buildings that already meet the ICC 500 standard, but essentially those don't apply. Huckabee, architects and engineers, all we do is K through 12 construction in the state of Texas. And we have 2 main offices in Dallas and Fort Worth. So this is something that affected us. It's very near and dear to our hearts, of course. And as such, I've become sort of a lightning rod for this issue as one of the major firms doing school projects going forward to try to resolve this issue. As myself, a structural engineer who's got a background in geotechnical, construction materials testing, mechanical, electrical, because it involves all of those different disciplines, and really they need to take a lead in the relationship with an architect as you develop the project. And I don't know how many structural engineers are in the room here today. Of course, the primary engineering firm in that discussion will be the structural engineer, because at the end of the day, you're trying to resist some very large forces. But it involves every single other discipline on the project in a very integrated, in a complex way. The zone affected by this change is the darkest region you see on this map, and that is about a quarter of the United States. The overlay of that map that we've done with the educational service centers show that all of DFW and other areas east and west of that would be affected. So when the local authority adopts the 2015 IBC, then you would have to have this for any new construction, such as a new addition to a school. The document that's referenced by that language is ICC 500. This is not equivalent to FEMA P361, which is an older document. That was a guideline. It was published by FEMA, and that was not a mandatory standard like this is. So what that means is that if you look at designs done by architects and engineers across the country using FEMA's standard, there are many people who disagree with one provision or another, or they're unaware of certain requirements in ICC 500. And what I'd recommend is that you wipe your mind of anything you happen to know about FEMA P361, because it simply does not apply. So start over and look at ICC 500. This document's very thin, very easy to read, and no matter who you are in this room, I highly encourage you to read it. And for those of you who are in the younger upcoming generation, I think this would be a great thing for you to read, because you're going to become more familiar with it with time than a lot of the people who are nearing retirement in this room, as we as an industry mature. Some of the main construction requirements are shown here, and I'm going to spend some time on this slide to give you an idea. There's a minimum 5 square feet per person of open floor space per person, and it's actually 10 square feet if you're in a wheelchair. It says open floor space. That means a table, chair, storage areas don't count. And that's important, because that means that you might have to have 50% more area than this to account for those unusable floor areas. You have to design for the 250 mile an hour wind speeds. That's associated with an EF5 tornado. That's about 4 times the typical wind pressures that you normally design for in our area of the country. You have to design for 100 pounds per square foot roof live load to account for all the debris that might pile up there. That is 5 times the typical roof live load. So right off the bat, you can see that retrofitting an existing building is generally not a feasible thing to do. On top of that, there's a lot of bureaucratic scrutiny that has to be done on a shelter, and you'll see for that reason alone, you really can't do a retrofit of an existing building easily. Debris impact testing. Many of you may have been familiar with the 2x4 missile impact tests, the gun that Texas Tech shoots in other areas around the country. You have to have that testing, and it has to be like a UL fire rating. So if you go decades back to when it was not common to have those UL fire ratings, if you didn't have a fire rating for what you wanted to build, you could not build it. And the same thing applies here. There is no analytically recognized method for justifying something as being debris resistant. There's no load you can say it meets. So because of that, you need to be very aware of and try to get your hands on debris impact missile testing data. For those in the room who may be civil engineers, you may think, oh, this is not going to affect me. This affects you. You have sanitary systems, for example, that will need to be protected, and finding the amount of cover that you will need above that. ICC 500 has 2 provisions that I'll go ahead and mention because it might be very appropriate to this room. It says for an underground shelter, it shows a picture with 12 inches of soil above it, and it has a clause in there right above that in the code reference where it talks about flat work just outside your shelter, where it says there's 0 PSF that you have to design for. The assumption, in other words, is that if you have 12 inches of dirt over any infrastructure, that protects you. That's not something explicitly stated in the ICC 500, but it's something for this group probably to be very aware of. Geotechnically, I'll say that one of the critical issues is sliding, because one of the things we normally don't have to deal with or don't have to be concerned about is sliding of our structures. But when you quadruple the lateral load, okay, when you actually run the math, the sliding of a shelter can cause it to move in an uncontrolled manner, and that's not acceptable. So what it would normally is something very easy for a geotechnical engineer to very conservatively estimate as the lateral capacity right? Passive pressure capacity. It becomes very critical in your design if you're doing a footing foundation, for example. L-pile analysis all of a sudden becomes very critical in a shelter. So geotechnically, you need to be very aware before your first soil report goes out on a project that might have a shelter. You have to have baffling, which is the diversion of any debris that might enter the space for any opening greater than 2 inches diameter. You may say, well, a 2x4 won't fit in a 2-inch hole, but a 2x4 is just the standardized debris for the testing. So you actually have to account for a pea-size gravel piece of debris, and you have to make sure that it will ricochet twice before it enters the occupied space. And of course, all the structural engineers in the room would love to just have no doors or windows or ventilation or piping for fire sprinklers, but reality is y'all make us do those kinds of things, and so we have to baffle anything that can come through so it ricochets twice, and that's actually a very big problem when you couple that with the requirement for a tested assembly. All right? The ventilation systems, you can have mechanically or naturally ventilated systems. However, if you mechanically ventilate, you have to have that on backup supply for 2 hours duration, which means you would have to have a generator. And a generator would need to be protected, and you need to naturally ventilate the generator. So most people would not choose to mechanically ventilate a tornado shelter. However, what I have found is most architects, unless you strongly steer them in the direction of what is acceptable and good practice, they will want to use the same prototypical plans that they've used 1,000 times over. And so it's very critical that you stop them in their tracks immediately, as early as possible in the project, and get them to consult, especially with the structural engineer in the project, to rethink it. Because if you have a gymnasium, for example, that you want to use as a shelter in the middle, then you'll find that it is landlocked with buildings all around it that don't allow for the natural ventilation, which means you need to redesign the entire footprint of the building, and most architects don't like to do that. Restrooms with sinks, handicap accessibility, 2-hour emergency battery backup, and a fire rating. Not firewalls. Firewalls have to stand up if the structure collapses on either side. We're talking about 2-hour fire-rated construction. And yes, I have had architects ask me if they can do a cantilevered firewall on one side of a shelter, and no, I did not allow that, and I don't recommend that. One of the questions is, where do you put it? Ideally, for code compliance, from an engineering standpoint, we would love it to not have any doors or windows and be its own box in the middle of nowhere. But we've found that most people don't want to support use of tax dollars for a separate dedicated standalone shelter. You could use it as a basement. We found that that has its complications because of all the reasons that building a basement in Texas is a complication to begin with on any other structure. You have to have handicap accessibility for one example. You have to control moisture. It has to be a habited space. So it's not like a crawl space in Oklahoma. 50 years ago, they would have just thrown kids in a crawl space if they had one. That is no longer considered acceptable because of all the other requirements. You could do a multi-purpose classroom or a single-story building, and we have done these ourselves. We've designed 9 shelters that are ICC 500 shelters, and to my knowledge, that's the most that any firm has designed in North Texas. And the problem with the tornado shelter is multi-purpose. With a classroom, is you have a lot of desks and chairs that you can't count as floor space for your shelter. So what we found is larger open spaces happen to be more economical in the sense that the area of the shelter is smaller, but the cost per square foot of designing construction for larger open spaces is more. Structurally, costs more to span an 88-foot span than it does to span with a grid line of columns at a corridor, 40 feet. So I think the industry will find its own solutions, but there are 2 flavors of shelters you find in the country. One is precast gymnasium shelters, and that's what we are doing a lot of. You could also do insulating concrete formwork or concrete masonry classroom shelters, and we've done our share of those. 2-story elements are problematic because of fire egress, and even though it's not explicitly stated in the code, when your shelter is activated, a door becomes a wall, and therefore it becomes a dead-end corridor for anybody outside the shelter trying to get in case you do not open that door. And so you might start thinking about all the protocols involved, and no, the code does not give you any guidance on when to activate, on how far to be, how far to place your students, to consider them within an acceptable distance. It does not tell you who's going to be in charge of the shelter or who's going to have control of the shelter. All of those things have to be done by a local emergency planning committee. and we'll talk a little bit about that later. From a broad visual standpoint, this is the West ISD new high school, middle school that Huckabee designed. I was the structural engineer of record on this project. And this is what the architect sees. This is what the owner sees. This is what the public sees. But this is what I see. You have to design a tornado shelter to withstand those loads, assuming everything else around it has been wiped off the foundation, and so you have to account for all of that. The heart of a shelter is what I call the shelter control room, and that's not a name for a room in the code, but when you think about all the things that need to happen, it's convenient to have a place for them. So we have a control room. And in that we have, first of all, restricted access to staff only, and it's separate from the host access control system. And you have a book of protocols, training and maintenance log, activation switches, because there are a lot of things that need to be activated in a shelter. One thing you need to activate is the system that would likely be closing off the ventilation during normal occupancy. Our owners aren't going to want to air condition the world, so a ventilation system is counterintuitive. It's not what you want in a regular building. So there has to be some way of shutting that off during normal occupancy. And that can be through a louver or a door, and you have to have a push-button control in the control room that will open that system so that the ventilation is free. You have a lot of hold opens for permanently open shelter doors that need to be released. You have the locking mechanisms to lock them down. You have to have the activation for water pressurization tanks if you have a water storage tank to keep your bathrooms operable for 2 hours. Monitors for cameras. You have to have people that recognize within the shelter when there's a person outside the shelter. And right now we don't have doors with windows in them. And so there's different ways that local emergency planning committees allow us to plan for the vetting of people. But in general, schools are not going to want the public beyond to come into their school. And this is going to be a very political conversation with each local school district. Because if you're a school district and you have to build a shelter for the number of occupants in the building, it would cost much more to design for a certain mile radius around your building for the local population to come in, and no one is paying for that. As a matter of fact, no one is paying for this requirement to begin with. So if you think about the politics of signage and what can they see from the street, and things like windows, and what do you tell someone that wants to get their child out but you're in lockdown mode, there's a lot of planning things that need to be considered. The backup power for the emergency lighting, anything else you have, all these other systems, automatic transfer switch, fire extinguishers, first aid kit, AED, then equipment for communication with the first responders, and possibly tools and equipment for a long-term evacuation plan. That is not the last one is not a requirement, but it's something that we recommend be considered by the local emergency planning committees. If you were to look at one of our gyms, you would see it's a very simple structure. We don't allow roof drains, and we have it naturally falling off one side. We have a 2-foot maximum parapet, and we do allow rooftop units. The doors, you can see, are not at the corner because the doors can only take a certain wind pressure. And it's actually counterintuitive, but the taller your structure is, the more wind pressure there is by ASCE 7, the wind code, which means that your door may not work. There are only so many doors that have been tested and passed the impact-resistant assemblies testing requirements, and those doors have a very high pressure, but they sometimes don't have high enough. And there are no doors that are made that have high enough pressure that you can put them anywhere. And when we've asked vendors over the years as we've been working with them and developing our prototypes, they say that there is no way for them to test the doors because their testing facilities cannot test at the high enough pressures that we want. So these may be a long time coming because all of these have to be UL labeled, and then that's a whole process in itself. One of the other things to remember with doors is that we have in Texas as well as Florida special requirements. Texas has the Texas Accessibility Standards, and many of you in the room who are civil engineers are very familiar with those requirements with regard to egress. There has to be an expansion joint, and there has to be a bottom strike for the bolt at the 3-point latch of the door to engage. That bottom strike needs to be above the floor level, which means you have to have a threshold because you would have a half-inch step otherwise, and that is not allowed by TAS. I mention that detail because that's one example of the small things that will get you on your first shelter if you do not pay attention. I'm giving a 4-hour presentation at the Building Professional Institute at UT Arlington if anyone would like to attend that and hear much more detail on it. This is an example of a cutaway showing a 12-inch thick precast concrete wall. That's not a sandwich panel. The brick veneer is sacrificial on the exterior. It does not have an insulation layer in between two layers of concrete, and that is pre-stressed. Double precast tees, something like 34 to 48 inches, depending on the span. And if you were to remove the top of the shelter, you'd see the rooftop units. Because those units might get sucked off during a tornado, we have baffling for the ductwork. These are the largest baffling systems on the job, and ideally, these are the only baffling systems on the job. If you can get all of the other disciplines to either do a 1.5-inch diameter pipe so that the penetration does not exceed 2 inches, or have them go down under the foundation perhaps and come up on the other side so it's protected by that 12 inches of dirt. And those are viable ways of avoiding baffling. But if you have to have some kind of ventilation system for normal occupancy, you have to have some kind of opening that will need to have a large system. We use steel plates and tubes and angles. If you look at an X-ray vision, you can see that there's ventilation on the left wall that you see where it does not have a baffling chamber, but it has two storm louvers that allow for double ricochet. If you look at the right-hand side at the back, you can sort of see a chamber, about a 10-foot by 10-foot room in which there's a lower opening, and then the air comes in, and the air has to come open over an interior wall before it goes through a louver into the space that's up high. You don't want to have louvers into the room that are down low, because kids can get sucked into the grate with the enormous pressure changes. One of the most complicated parts of a shelter is the baffling chamber for the lower ventilation that we do. If you want to work with your architects at the beginning of a project, you can find that there are many new relationships that many of them, other than Huckabee, many of them are not used to working with. First of all, there is a local emergency planning committee, and we are telling our clients, we're giving them the very brief reference to that term in the code, and we're helping them with their legal department, and most of them are establishing a local emergency planning committee by having the school board nominate and elect a committee to be in perpetuity with certain positions. So, for example, it might say the board president, the superintendent, and the chief financial officer of the district, whichever people are in those roles throughout perpetuity for the planning and the operations and the maintenance of these facilities, these tornado shelters. And you also have peer reviewers that are required, and unlike normal peer reviews, these peer reviewer reports have to go to the authority having jurisdiction as well as the local emergency planning committee. So this has a lot of teeth in it. And the reason for that is because there have been studies which have shown that many tornado shelters are not properly designed. So I would encourage you to work with peer reviewers early in the design phase if you haven't done a shelter before. And the bottom left, you can see I've got the authority having jurisdiction, which many of you may say that's not a new relationship. Oh, yes, it is. The authority having jurisdiction can veto, essentially, the feasibility of a shelter. And if a shelter is required to build a school, that means the city can kill a school project. So a district may have owned a piece of property for 20 years, intending to build a high school there one day, and then come to find out that the city is going to require their minimum finished floor be, 300 feet above the existing grade. So you can have a deal breaker, and you need to vet those things early on. Things like hazardous materials storage. There's some clauses in there because ICC 500, as Alexis mentioned, was not written to be used as a mandatory requirement for schools and first response centers. That is something that FEMA changed after the standard was written at the last minute. So keep that in mind, that there has to be some adaptation. And I've been working with the local structural engineers associations of Texas and Texas Association of School Boards, Texas Association of School Administrators, U.S. Department of Education, all trying to help us as an engineering community come to a consensus on what is the appropriate interpretation here and there with regard to schools. The cities are going to have an easier time applying this standard to their own facilities for fire stations and jails and police stations, obviously, because they're the owner. The challenge here is going to be, for example, getting the city to recognize that the school district's local emergency planning committee is the appropriate LEPC. And every time I've talked with the city, at first they say, no, we're the LEPC. But once I go through that, they realize there's a lot of liability there. They don't want to be the one determining when to activate, training new staff, and determining how far a special needs child is from the entrance to a shelter on a daily basis. And so they then back away. They say, no, that's the school district's responsibility. So the owner structural engineering observer is something else that's going to be very important for this crowd, the bottom right-hand corner, is because from a testing side, you need to be aware that there's a requirement in the code that you hire a licensed design professional. The way we interpret that is someone who is either listed as a structural 1 by the Texas Board of Professional Engineers, or a structural 2, or a structural 16, or listed as someone recognized as practicing in the structural field by the Texas Board of Professional Engineers. So if you are a testing lab and you do not have anybody on your staff today, I would go looking through my resumes when I got back to my office, and I would try to hire the appropriate people now, because that wave will be coming. Bonds just passed for a lot of work on Saturday, and so work will begin pretty soon on those projects. And with that, I think I'll open it up to questions. Is that fair? I know that's a lot. I was trying to squeeze it in. Hope it